Losing a limb can be a life-altering experience, one that reshapes the very fabric of a person's existence. It can impact every aspect of a person's world, from basic tasks like brushing teeth or tying shoelaces to more profound elements like personal identity and self-worth. But imagine a world where losing a limb doesn't mean losing your independence or your ability to live life to the fullest. Picture a future where technology bridges the gap between disability and ability. This is the promise of robotic prosthetics, a revolutionary leap in medical technology. These aren't the static, artificial limbs of the past. They are dynamic, responsive, and incredibly lifelike. We're talking about devices that mimic the natural movements of the human body with remarkable accuracy, allowing for fluid and precise actions. They are controlled by the user's thoughts and intentions, thanks to advanced neural interfaces, allowing for a level of integration and control never before seen in prosthetic technology. Robotic prosthetics are empowering amputees to regain lost abilities and even surpass their previous limitations, opening up new possibilities for personal achievement and independence. This technology is not just about replacing limbs, it's about restoring lives, giving people the tools they need to reclaim their futures and pursue their dreams with renewed vigor and confidence. Early prosthetics focused primarily on functionality, replicating basic movements like gripping or stepping. Today, the field is rapidly evolving towards intuitive and responsive devices. We're seeing advancements in areas like myoelectric control, where sensors detect electrical signals from the user's muscles, translating them into fluid prosthetic movements. Imagine thinking about reaching for a cup of coffee, and your prosthetic arm responds seamlessly to your intention. This level of intuitive control is becoming a reality for many amputees. Microprocessors within the prosthetic limb interpret muscle signals, learning the user's unique movement patterns and adapting accordingly. One of the most exciting advancements in robotic prosthetics is the development of sensory feedback systems. These systems are revolutionizing the way users interact with their prosthetic limbs, making them feel more like natural extensions of their bodies. These systems allow users to feel through their prosthetic limbs, restoring a crucial element of the human experience. Imagine being able to sense the warmth of a cup of coffee or the texture of a piece of fabric through a robotic hand. Using sensors embedded in the prosthetic, information about pressure, temperature, and texture is relayed back to the user, either through vibrations on the skin or targeted nerve stimulation. This technology mimics the way our natural limbs send sensory information to our brains, creating a seamless experience. This sensory feedback isn't just about enhancing comfort. It's about restoring the brain's natural connection to the limb. When the brain receives sensory input from the prosthetic, it begins to integrate the limb more fully into the body's schema. This connection is crucial for improving control, dexterity, and even reducing phantom limb pain. Phantom limb pain, a common issue for amputees, can be alleviated when the brain receives accurate sensory feedback from the prosthetic. It allows users to interact with their environment with greater confidence and precision, whether they're picking up a fragile object or walking across uneven terrain. The ability to feel and respond to sensory input makes everyday tasks easier and more intuitive, significantly enhancing the quality of life for prosthetic users. The journey of using a robotic prosthetic is a testament to the incredible adaptability of the human body and the power of human-machine collaboration. It requires dedication, patience, and a willingness to learn new ways of moving. Physical therapists play a crucial role in this process, guiding users through exercises designed to strengthen muscles, improve coordination, and master the control of their new limb. This is not just about physical rehabilitation, it's about retraining the brain to recognize the prosthetic as an extension of the body. With each successful movement, the connection between the user and their prosthetic grows stronger, leading to greater confidence and independence. The true measure of any technology lies in its impact on people's lives. And the stories of amputees using robotic prosthetics are stories of remarkable resilience, determination, and the unyielding human spirit. We see individuals who, after losing limbs in accidents, have returned to their athletic passions, competing at the highest levels with the help of their prosthetics. We see artists who have found new ways to express their creativity, using their prosthetics as tools for painting, sculpting, and playing music. These stories are not just about overcoming adversity, they are about embracing new possibilities and redefining what it means to live a full and meaningful life. Despite the transformative potential of robotic prosthetics, significant challenges remain in making this technology accessible to all who need it. The high cost of development and production often translates to exorbitant prices, putting these devices out of reach for many amputees, particularly in low-resource settings. Furthermore, insurance coverage for robotic prosthetics is often limited, leaving individuals to navigate complex and often frustrating bureaucratic processes. Addressing these challenges requires a multifaceted approach, involving collaboration between researchers, policymakers, healthcare providers, and advocacy groups. The field of robotic prosthetics is constantly evolving, driven by a relentless pursuit of innovation and a deep commitment to improving the lives of amputees. Researchers are exploring new frontiers in bio-integrated prosthetics, where the lines between biology and technology become increasingly blurred. This includes developing prosthetic limbs that can be controlled directly by the brain through neural interfaces, bypassing the need for muscle signals altogether. Imagine a future where prosthetic limbs can not only move and feel, but can also communicate directly with the brain, restoring a level of integration that was once thought impossible. As we continue to push the boundaries of what's possible with robotic prosthetics, we move closer to a future where limb loss no longer represents an insurmountable barrier to living a full and active life. We envision a future where these devices are not just tools for regaining lost function, but instruments of empowerment, enabling individuals to achieve their full potential. This is a future where technology helps to level the playing field, providing amputees with the tools they need to participate fully in society, pursue their passions, and contribute their unique talents to the world. It's a future where disability is not defined by physical limitations, but by the boundless potential of the human spirit. The journey of robotic prosthetics is a testament to the power of human ingenuity, resilience, and our unwavering pursuit of a better future. From the early days of rudimentary designs to the sophisticated lifelike limbs we see today, this evolution showcases our relentless drive to overcome challenges and improve lives. Modern prosthetics work by integrating advanced materials, sensors, and artificial intelligence. These components mimic the natural movement of limbs, providing users with unprecedented levels of functionality and control. Sensors detect muscle signals from the residual limb, which are then translated into movements by the prosthetic. The sensors and AI work together to create smooth, natural movements. For instance, when a user thinks about moving their hand, the sensors pick up these signals and the AI processes them to move the prosthetic hand accordingly. This seamless interaction between biology and technology is transforming lives. This is a journey that demands our continued commitment, collaboration, and investment, ensuring that these life-changing technologies are accessible to all who need them. Researchers, engineers, and medical professionals must work hand in hand, sharing knowledge and resources to push the boundaries of what's achievable. Together, we can create a world where limb loss is no longer a sentence of limitation, but a catalyst for innovation, empowerment, and the celebration of human potential in all its forms. By fostering a culture of inclusivity and support, we can ensure that every individual has the opportunity to thrive and contribute to our shared future.